In this video, we'll talk about chain rule, and we have two situations. The first one is when we have a function z that is a function of x and y, and x is a function of t and y is a function of t. So x and y are functions of only one variable, and that's t. If we need to calculate dz dt, then using chain rule, we get dz dx times dx dt plus dz dy times dy dt. So this is a formula that it's important to know when we want to differentiate a function of multivariables, and each of those variables is a function of only one variable. So let's do this example. Let's find dz dt if z of xy is given by 2x squared plus 3y, and x is a function of t, x of t is sine of t, and y of t is square root of t. So let's write the formula first. So dz dt is equal to dz dx times dx dt plus dz dy times dy dt. So let's begin. So dz dt equals dz dx. So we look at the function z of xy, and we differentiate it with respect to x, which means y is a constant. So 2x squared prime is 4x times, so we did this piece, dx dt. So we go to the x of t function and we differentiate with respect to t. So sine of t prime is cosine of t. Plus, now we are here, dz dy. So we go to the yellow function and we differentiate with respect to y, which means x is a constant. So we get 3y prime, which is 3, times dy dt. So we go to y of t, which is square root of t, and we differentiate with respect to t. So square root of t prime, it's 1 over 2 square root of t. So here we can go one more step where instead of x we put the function of t, and we get 4 sine of t cosine t plus 3 over 2 square root of t. Now let's talk about the second situation where our function z is a function of xy, but x it's a function of two variables ts, and y is a function of two variables ts. So in the previous example we had x as a function of t only, now it's a function of t and s. So then we're gonna end up with two derivatives, zt, which is dz dt, and zs, which is dz ds. So using the chain rule, we get dz dt is dz dx times dx dt plus dz dy times dy dt, and dz ds is dz dx times dx ds plus dz dy times dy ds. So having these two formulas, let's solve a problem. So let's solve the problem. Let's say we have z of xy equals square root of x plus y, and x is a function of t and s, which is equal to t to negative 1 plus s, and y is a function of t and s, and it's t plus s. Sometimes you can have the functions written of other variables or of st. So let's calculate z t. So that means dz dt, which is dz dx times dx dt plus dz dy times dy dt. So that means dz dx is, we look at the function, this is our function, and dz dx is given by 1 over 2 square root of x plus y times dx dt. So we have to differentiate this with respect to t, Well, t to negative 1 prime is negative 1 t to negative 2. So we have times negative t to negative 2 plus dz dy. So now we go back to the green function and we differentiate it with respect to y. So that gives us 1 over 2 square root of x plus y would be times x plus y differentiated with respect to y, which is 1, times dy dt. Well, if we differentiate this with respect to t, we get 1. So this function is equal to, we can put negative in front, 1 over, I can move this t to negative 2 as t to the second, and then 2 square root of x plus y. So I can say t to negative 1 plus s plus t plus s, so that would make it 2s here, plus 1 over 2 square root of t to negative 1 plus t plus 2s. So this would be the derivative of z with respect to t. Now dz ds is dz ds, which is dz dx times dx ds plus dz dy times dy ds. So dz dx, again, we went through that, it's the same thing, so it's 1 over 2 square root of x plus y times dx ds. So now we differentiate this with respect to s and we get 1, because this one, the t to negative 1, is constant, plus dz dy. So again, we go to the green function and we differentiate with respect to y. We get 1 over 2 square root of x plus y times dy ds. We differentiate this with respect to s, we get 1. So we get 2 over 2 square root of x plus y, which we actually get 1 over square root of x plus y, right? We can cancel this and end up with 1. So that is equal to 1 over 2 square root of t to negative 1 plus s plus t plus s, so 2s here.